Okay, so welcome to Introduction to Organic Naming and Functional Groups. We're going to review real quickly the things we had last time that we learned. Remember that methane is CH4. Okay, so this is a review real quick. Remember the song? 1 is methane, 2 is ethane, 3 is propane, 4 is butane, 5 is butane, 6 is hexane, 7 heptane, 8 is octane, 9 is nonane, 10 is decane. Now you've got it. You can name organic chemicals if you know these 10. All right, so what we need to do is we need to be able to name organic chemicals. So if I draw this, this is what is known as a skeletal structure. It basically represents this, which is a condensed structure. I can also show my hydrogens coming off, which is expanded. And by putting ticks here, I'm representing my hydrogens, and an expanded version would actually show the hydrogens, but it's the same molecule. I will use the skeletal form a lot in drawing diagrams so that you can see what's going on. Since there are 5 carbons here, try that again. Yeah, there are 5 carbons. I think I did. So 5 carbons would be pentane, and that's what I would name it. It has a single bond, so it's an ANE and an ND. Now if I took those 5 carbons and put them together a little differently, like this, I would want to find the longest chain. And I don't want you to get used to using the longest chain in a straight line. But you want to do the longest chain, and you want to count according to, you want the numbers of the things coming off to be the lowest numbers. So I'm going to start here, and I'm going to go 1, 2, 3, 4. That leaves this coming off. And I like to use color pencils when I'm doing organic naming, and always use the same color for methane and ethane and propane. So this is a methane group. When it's attached, we change it, and it's called methyl, YL. We change it to YL ending. So we number what carbon it's coming off. It's coming off carbon number 2, so we call it 2 dash. Anytime we go between numbers and letters, we use a dash. So 2 dash methyl. And the longest group is 4, which is a butane, and we just smash it right into it, butane. These are not Englishly or grammatically correct. We use it to tell us how to draw things. Let's do a few more. So here I have this compound. Now, looking at this compound, I can name it either, or start at either end and number towards the center, and things come off both at number 3. But if I start on the right and go to the left, I actually have 2 things coming off at number 3. So 2 things beats 1, so I go ahead and number 1, 2, 3, 4, 5, 6. So I have a hexane, and I have 1, 2, 3 groups of 1 coming off. Now groups of 1, remember, were methyl, and I'm using my green still for methyl. So now I go about writing the compound. I say where they're at, so 3, 3, 4, dash. Now it's sort of redundant, but I've told where they are at. Now I have to tell how many. Well, there's 3 of them, and the prefix for 3 is tri. And then they are methyl groups, so I put methyl. Then I put my longest group, which is 6, which is hexane. And I'm done. Okay, let's look at another one. Okay, I'm a little tricky here. So the longest one is not the straight line. So look carefully. Which is the longest way to go? Now, if I count both ways, 1, 2, 3, 4, I'm going to end up 4 with 2 things coming off. Now what do I do? Well, now you look at what groups are coming off. So I'm looking at the groups, and I've got an ethyl group, which is a 2-carbon group, and a 1-carbon group, which is methyl. Now I do alphabetically. So ethyl wins. So I go ahead and number starting this direction. 1, 2, 3, 4, 5, 6, 7, 8. Then I take and I circle my methyls with my green, and my ethyls I'm going to use blue to circle them. Now when I go to name it, I name it with my ethyls first, because alphabetically they go first. So 4, there's 2 ethyls, that's di for the prefix. Then I put ethyl, remember changing the N to YL because it's attached to something, so it's no longer ethane. Then I put dash, and at 5 and 5, there is dimethyl, 2 groups of methyl. Then the longest chain is 8, and it's an octane, so I go octane. I've got the name. Okay, so pretty easy. I'm going to do one more, and I'm going to have you stop the video and try it on your own. So here we go. Okay, so stop the video. Come back when you got it done. All right, this is what you should have done. This is the longest chain. You have 2 methyl groups, and you have 1 propyl group. Again, I'm still using different colors for each group coming off. So my final name, propyl and methyl, methyl comes first. So I'm going to tell where my methyls are. So 3, 6, dash, di, because there's 2 of them, methyl, dash, 5, dash, propyl. And then the longest chain is 9, which is non-ane. Right? Okay, let's go on to functional groups. And we'll be practicing these in the next several videos, but I'm just going to introduce them and give you an idea what of each of these are, because we're doing that lab in class that you need to be able to build these. So the first functional group that we're going to talk about are alcohols. Okay, alcohols have an OH, and we use OL. We replace the E and put OL. So if I have a chain that goes like this, that's a 3-carbon chain. 3-carbon chain is propane, right? So I'd write propane, drop the E, and add OL. Now I do need to tell it where that OL is coming off of. Here it is coming off number 1. I could also have had this, which would have been 2-propanol. So I number just like I would any other thing. I can have 2 alcohols coming off, like this. In that case, I would have a 1, 2 dash propan diol. So I have 2 alcohols, the diol. Now, you got to be careful, because as we get more and more that change the ending, you could have several things on one thing. So when we have more than one thing that's changing the ending, we put it inside. So it becomes right before the change in ending. So we could go propan dash 1, 2 dash diol, like that. So if we have more than one ending, that's what we do. Either of those is acceptable if I only have one. Now, if we go on to the next one, the next one is an ether, and I like ethers. Ethers are fun to name. They make me feel like I've got a list, though. Either this or that, okay? So if I have C-C-O-C, I would know that this side right here is an ethane group, and this side right here is a methane group. So I label it alphabetically and change the ending to YL. So I go ethyl, methyl ether. Pretty fun. Now another way that you can look at this is they can do line diagrams. So they can go like this. I like drawing this one around Halloween time. But what happens is that each of those corners right there, those represent hydrogens. I mean not hydrogens, carbons. So I've got 2 carbons on either side of the oxygen. So to name this one, this would be diethyl ether. So I have 2 ethyls. All right, so that's how you make ethers. Going on to the next one, we go to amines. And like I said, I'm hitting these fast. We'll go back and in subsequent online lectures, we'll go in depth a little bit more. An amine basically has some kind of nitrogen at the end. It could have something attached to all of them. It could only have one chain. It can be whatever. So what you do is say that I have a carbon chain that ends like this. That carbon chain there is an ethane. So I would just say ethyl amine. Done. I could also have a carbon chain like this attached. This is also an amine. I have an ethyl, a methyl, and a propyl attached. I just name them in alphabetical order. So ethyl, methyl, propyl, amine. Okay. Next group that we're working with is aldehydes. Aldehydes end a carbon chain with a double bound oxygen, single bound H, and we change the ending to Al. So sort of like alcohol, but it ends in Al instead. So the simplest one is just methane. Methane will be methanol, Al. Common name is formaldehyde, aldehyde. Okay, so if you go a little bit farther, we could have, which would be 5, so it would be pent, tan, al. On these ones, you do not have to put numbers because it's always on the end. You could have a dial, having it on both ends, but that's all. Okay, next one is a ketone. A ketone is a double bound oxygen all coming off a carbon in the middle of a chain, and we change the ending to ONE. And you have to tell where it's coming off. The smallest chain that can be a ketone is a 3-carbon chain because it has to come off the center one. So this one would just be propanone. We don't have to put the number in front of that because there's only one place it can come off. Same thing with butane, because butane can only come off one way. It had to be 2 butanone, either way. But after that, when we start getting to 5, we need to tell where it's coming off. So again, if it's just that that's changing on the end, we can put it in the front, so it can be 2 pentanone. But if there's more than one ending changing, then remember you put it inside right in front of it, so it would be pentan 2-one. All right, next group, carboxylic acids. A carboxylic acid is at the end of the chain, double bound oxygen, single bound OH. And we go and change the ending to O-ic and add acid. So this would be ethane. Ethane is now changed to an acid, so we go F and O-ic acid. This has also got a common name of acetic acid, which you probably know as vinegar. It's dilute. Acetic acid is vinegar. All right, going on, we're running out of time, so I'm going to go quickly. We've got an ester, is another group. Ester is a carbon chain double bound to an oxygen. So I'm just going to, let me redo that. So I've got a carbon chain, double bound oxygen, comes to single bound oxygen, comes to another chain. Okay? So this is made from an acid. This side was an acid combining with an alcohol. This side was the alcohol, and giving off water as they combine. So when we name it, we're going to name the alcohol side first, then the acid side. So here is an ester. We're going to name the alcohol side, which is the methyl. Then we'll name the acid side, which is the 2-carbon, which is ethane. And we change the ending to E to O8, and we're done. These are smells. These are things that are nice to smell. So let's do one more. We got C, C, C. So we got this time ethane, so ethyl. Then we got a propane, so we're going to go propan O8. All right, the very last one is an amide. An amide is like an ester, but instead of having the oxygen connected, it has a nitrogen connect. So you just go like this. This would be methyl, ethyl, amide. All right? Okay, I'm going to stop here. We'll go about more on the next time. So you got the main ideas. I know I went through it fast. We'll pick each one apart later.